guys, we are continuing our examination of density here. And so we're looking at two objects. First, I have a tea light candle. The wick has just dropped out of it. Let's see. Just so you can see what it is here. There's a candle. And I've got a piece of clay. So which one do you think would be heavier? Tea light candle, piece of wax, or piece of clay? I'm going to set the clay on my balance here. You might have used a balance before, but just in case you have not, all this is showing us is which one is heavier. It's not giving us an actual weight. So you can see down here, there's the scale, and it's not giving us, grams or anything like that. It's just which one of these is heavier. It is literally a balance, like a seesaw. All right, so here comes the tea light candle. All right, think about that. Which one is actually heavier? All right, so hopefully you said that the wax is heavier, which I found a little bit surprising. The clay seems very dense, and the wax doesn't seem as dense, but the tea light candle was heavier because it weighed down one half of the balance. All right, so let's bring in our cup of water here. And I've still got my candle, and I still have my ball of clay. Which ones do you think would float, and which would you sink? Which would you think would sink? Let me try that again. All right, here comes the wax. This is the heavier object of the two. And you can see it is floating in the water. What do you think the clay is going to do? It's lighter than the wax. And here we go. And the clay sinks like a rock. So why do you think that would happen? The heavier candle is floating, the heavier wax is floating, the lighter weight clay has sunk to the bottom. Think about that for a minute. All right, we're taking the next step now in our density exploration here. So I have the tea light candle that I have taken the wick out of. The wicks just drop out of this. But I use the wick to pull the candle out of its metal cup. This is what a tea light looks like when you buy it at the store. It's a small candle inside of a metal cup, right? All right, so I'm gonna set that there where you can see it, so you know there's no magic trickery involved. But I need this metal cup here. I'm gonna fill that cup with water. Thought I left and went home, didn't you? All right, so here we go. Fill in this little cup with water here. Hopefully I won't be making a big mess. All righty. It is full, and it is squishy. All right, let me bring the camera up over the top just so you can see it's full, and I am not fooling with you. And bump this a little bit so you can see the water move. All right, so we have a cup full of water here, and our examination is to see if that same volume of wax is heavier than the water or lighter than the water. So here comes the tea light. Okay, and what do you observe? I've got water on this side, the same volume as I have of wax on this side. So hopefully you see that the water is apparently heavier than the wax is because it is weighing down the balance here. All right, so on your student activity sheet, you have questions as you get down towards the bottom here. And the question is, which weighs more, wax or an equal volume of water? So now you should be able to answer that question. What I need you thinking about is which is more dense, wax or water? So which weighs more and which is more dense? Okay, we've compared the density of clay and of water. I'm sorry, wax and of water. Now we want to compare the densities of clay and water. So I have my freshly emptied cup here that I had water in. I've poured that back into this container, so that is now empty. I have another tea light that's intact, and I'm gonna pull it by the wick and take the tea light out. So I have a second cup here. Put that on the scale. Get it centered there. And you can see that they weigh the same. The scale is balancing. All right, I'm going to take one of these and I'm going to fill it with clay. See, I'm mashing clay into the cup here. I need just a little bit more to make that a full unit. The difficulty is that the cup is pretty fragile. Oh, sorry about that. The cup is quite malleable, we could even say. It is made out of aluminum, so that as I'm mashing things in there, I'm altering the shape of the cup a little bit, which is not something I really want. Okay, so what you can see here is that I have filled this container with clay. So obviously the container filled with clay is heavier than the container with nothing in it. So what we're going to do now, I'm going to bring this back close to you so you can see. What we're going to do now is fill this cup with water until we reach a point where the balance drops. If we can get to that point, we'll see if clay is more dense than water here. All right, that cup is full. Let me again bring the camera up over the top so you can see. I'm going to ding it a little bit here so you can see the water in it. All right, so with the container filled with clay and this container filled with water, the balance did not change. So which one would you say is more dense, water or clay? Now, as you think about this, go back to when this was a ball of clay and it sank to the bottom of our cup here. And can you explain perhaps why that might have happened? All right, back to our activity sheet again. I'm on the second page. I've turned it over here. And let me get something behind it so the light's not shining through it. All right, and this is the procedures that we just did here, and you've got some questions down here that you need to answer. And these are the questions that I was just asking you. When you think about the density of clay and the density of water, why would the clay sink in the bowl of water? And then think about what that means for whether objects will float or sink. And that's what you're answering on this page. All right, here we are back with your student activity sheet. And on this side, we're looking at the molecular structure, the atomic structure of what water would look like, how densely together the molecules are packed of hydrogen and oxygen that makes up water. Over here, we're looking at how wax is formed. So wax is made of carbon and hydrogen atoms connected together in long chains. So you can see these chains in the image here. And these long chains are tangled and intertwined and then packed together to make wax. So both of these things have lots of hydrogen atoms, but water is more dense than wax because the oxygen in the water is heavier and smaller than the carbon in the wax, so there are more atoms packed into that volume of space. Also, the long chains of the wax do not pack as efficiently as the small water molecules. So when you look at a chunk of wax like this candle, there's a lot of space in there at a molecular level. You can't see the space. The whole thing feels like it is dense, but when you get down to the atomic or the molecular level, there's a lot of space in there that water just doesn't have. All right, down here is our image of clay. And clay has oxygen atoms just like the water does, but it also has heavier atoms like silicon and aluminum. The oxygen atoms are bonded to the silicon and aluminum to make molecules with a lot of mass, and then packed very closely together, which makes our clay much heavier than the water, which is why no matter how much I filled our little cup of water here, I could not get it to be heavier than this clay for the same volume. Now, if I put a big beaker of water on, I could have matched that, but then we're not comparing density and density. All right, and this is the last section that we're going to do for this part of the lab. This is your activity sheet. This is actually the 2 pages of your activity sheet. So you have a question up here about a giant log can float on a lake while a tiny grain of sand sinks to the bottom. Explain why the heavy object like the log floats while a very light grain of sand sinks. So you got to think about that and then write your answer in the space here. This is set up as a CamiDoc so that you can just type right on there. On the table here, you are given densities of certain objects over here, and you need to predict whether they'll sink or float. So you can just write sink or float over here. And again, you can type that in as a Cami document. And on the last page, you have 2 more questions here about density and what you can say about mass. They give you the volume of a peach, and they tell you that it sinks in water, so what would you guess about its mass? And in this one, if a banana has a mass of 150 grams and floats, what would you say about its volume? So they're not the same question, but they're very related, and it's all about density. Remember, density equals mass divided by volume, and that's what they're driving at here, is getting you to think about those things. All right, fill those out. That's a Cami assignment, so it'll come to me automatically. I'll see you soon.